Our next talk is about suitably terrifying Furbies. So Luke McNeice, who is the head of engineering and also the site lead at Hamilton Robinson, is going to take us on a journey to crack the Furby code and unlock its hidden potential.
It's 1998, and I, here, 10, studying for my 11 plus, certainly don't even know what hard work looks like yet. Google was just getting started. I'm not sure Apple's web technology got much better than this. Although I do think they had peak marketing here. Titanic also hit the box office that year. And here, Leo, about 25, is still older than most of his recent girlfriends. It was also the year that Tiger gifted us with the Furby, the first successful attempt at an interactive robot pet. The school playgrounds were all over the world were a frenzy. It was all everyone was talking about in my school. And once the marketing was in full swing, lest we forget the Christmas riots of '99. Furby went on to sell 40 million units in 24 languages in the first 3 years of production alone. This is all at a time when viral marketing wasn't cheap or easy. Impressive even by today's standards. There's so much chaos here that it's easy to miss. There's no smartphones. It's refreshing. Or this cheeky chap going for a sneaky self-serve. I also want to know what this guy's vibe is. I mean, being physically restrained in a children's toy shop is an achievement. That's a man who's been told if he doesn't come home for Christmas with Furbies, that he's sleeping on the sofa. So thanks for coming, everybody. Has anybody went to my last talk? It was about 2 or 3 years ago. Can I have a quick show of hands? Awesome. Some of the content will be the same. I've got a few extras, though. At this session, I'm going to share my journey reverse engineering Furby. And I hope there'll be something for everybody. I'll share the setup that I use to explore Furby's capabilities. We'll dip into the original source code and see what the 90s called a learning machine. And I'll talk about Furby's best kept secret, what enabled it to become the toy of the millennium. I'm Luke McNeice. With a mechatronics background, I started off developing FPGA technologies for internet service providers for Nortel. And as a grad, I joined Kainos and delivered some of the first B2B iOS and Android apps to UK banks and hospitals. Now I lead Guild, their organization that delivers software services at Hamilton Robinson. We're a mix of software and hardware engineers working with customers like X, TikTok, Reddit, Datadog, just to name a few. Some of our current enterprise projects are a secure identity and right-to-work platform, checking platform in the UK, recruiting, UK National Archives environmental monitoring, and an IoT office space analytics product that helps companies manage their office space. Some of the more recent creative projects include digital services and interactives for many science museums. And if you went to the Our Place in Space kind of tour that was up at Black Mountain, and it toured around the UK and beyond, I was involved in that too. And an interactive longbow that feels real at the Game of Thrones studio tour. I have a strong belief that environments drive behavior, and creating opportunities for engineering teams to prioritize both quality in structured teams and simultaneously creativity in flat teams is an effective, I think, a way of attracting talent and developing people. But I'm sure you're wondering how I got here. But here, for me, actually started in 2014. This is my son, Sam. Here are 3. And after a nostalgic garage sale find, my sister, still traumatized by a jealous me continually hiding her Furby, of course for maximum jump scare effect, brought one home. And naturally, Sam was pretty happy about that. We named him Frank, and it was all going really well until I put batteries in him. Sam was terrified. There was tears shortly after this. So what is any father to do? At first, I thought, torch it, but saner heads prevail. So I took a walk to the bottom of the garden, dug out the tools that I needed, and dissected the little demon. Frank to be clear. And for Boy, watching this, it worked. Starting off a now long tradition of science and maker lessons at home. And yes, that is a Hulk Hogan torso strapped to a remote control car. It's a bit Sid from Toy Story, right? But we'll let him away with it. And of course, it was only once Furby was disassembled in bits on my kitchen table that Sam leaned in and whispered, "You can't talk now, Frank." But wanting to grow that STEM spark, this got me thinking, what would it take to make Furby talk? I'm not the only one to be experimenting with Furbies. And many of you, I'm sure, have seen, and if you have not seen these things, you're in for a treat. If you just weird Furby, this and many more, weird Furby, just search for this. But some of these are good content. I actually wasn't a fan of this model of Furby. It was something about the eyes. But the original Generation 1 had potential. And it speaks to something I think really primal, that believable eyes are almost all you need. And with original Furby having just expressive eyes, if it passes the meme test, it's all good. So I got started, and there was a prototype. Then there was lots of prototypes. And with each one of these, I was trying to figure out how to control individual components to maximize expression. Started with the mouth, moving to the eyes, tried to put them together, didn't really work, back to the mouth, all sorts of things. But all very performance-led, much like an engineer. And after a year of this, everyone was looking a bit worse for wear. And I was lost. So what is an engineer to do when they're lost? Well, they create a JavaScript framework, but in fairness, that wouldn't help here. When I'm lost, I write documentation. And as it often does, it helps me step back to see a bigger picture. Why did we have to do any of this? Was it possible to keep Furby intact? It seemed like such an obvious question now. So let's change it up and jump in some of the source code. So actually, the source code only leaked relatively recently, and it is a very, very well-documented 297 pages of assembly, which, if you've ever worked with assembly, isn't actually that much. And in fairness, the speech chip firmware is missing, and so I would expect that to be quite a lot. And inside Furby, basically, you have like two big chips. You have the speech synthesis chip and the Furby CPU. And actually, this was one of the first toys. There was two or three toys kind of just before it. And actually, you might know about one of them. So if you haven't watched *Halt and Catch Fire*, it's an amazing show, and especially if you are like an engineer or you're technical and you have like a non-technical partner, you can enjoy that together. It's lots of really cool storylines in there. But in that show, one of the characters, Donna, she's like a technical savant, and she was credited to be building the first Texas Instruments chip, and that's what made it into the Furby. And one other little tip was that for a long, long time before the source code leaked, it was guessed that the assembly was built for an Apple II chip, one of the early Apple II chips, because it seemed to be the only thing that could do the job, would be this powerful at the time. But actually, what had happened is that the Apple had actually licensed some of that technology to like cheaper brothers and sister chips, and it was a slightly cheaper one. And it was really hard to know that because one little quirk as well is this black resin that you see, this black dot. It's actually very typical of 90s toys and hardware. If you ever open up like a 90s toys hardware, you'll find that. And basically it's an artifact of how bad digital security was. That this actually was the way that people secured their IP. They basically put resin over the top, and the only really way to attack it was to try and get basically this really dangerous acid and etch it away and try and see what was it connected to and things like that. And I thought that was really cool. So at the time, it was such a big jump from any other toys. You might remember also Tamagotchis kind of came in and around the same time as well. And I had one, it was cool. I probably lasted maybe a couple of months. But Furby had all of these really engaging capabilities, and I had this idea of that it learned English from you. Actually, there was a court case in the US, of course, after about 3 or 4 years after its launch, and someone took it to court because the child got the Furby, taught it swear words, and the parents took Tiger to court. And the funny thing is, they settled out of court, and you'll see why, because it doesn't learn English from you. Of course, how could it? It was 1998 build. Now, what I found in the source code was that it effectively had like tables where, started off 10% of the table was English words, and 90% of the table was Furbish words. I'll talk a bit about Furbish in a second. And basically, as it got older, that kind of percentage ratio basically just ratcheted up. And if you engaged it, it continued to drive that kind of ratchet and the acceleration of the age. So it appeared to engage with you. And it had a game called Simon Says, which appeared to kind of copy you and things like that. So it kind of was just a bunch of really clever tricks. Random numbers actually was really, really hard to do, especially in low power hardware in the 90s. It's very, very easy. I mean, certainly in our frameworks we have today, you just call it .rand and you get this amazing random number that is truly random. But it was really hard back then, and Furby solved that problem in a really, really interesting way. So one of the things that I spotted where it kind of used the random number generator was that it seemed like everybody in the playground had a different personality in their Furby. I thought that was fascinating at the time, and I wondered, of course, how it was done. And in the source code, it was very clever, very simple, but very, very clever. And basically, when it first boots, it uses the ambient light that's in the room at the time, the tilt angle, a few other different things, and basically seeds all of those numbers together and uses that to select randomly a voice. So one of 3 voices, you could have a deep voice or a high voice. But also, I remember looking in the source code and I couldn't figure it out when I first seen it, and it had set a bunch of weightings that it then stored and used forever against the sensors. So for example, if it was playing hide and seek, the light level would appear to be worse or better. And this kind of corrupted, and I did that for all of the sensors. And when you restarted it and I got a new personality, it set a bunch of new settings for that too. And I didn't understand why it had done that. But actually what ended up happening was it led to your Furby ending up becoming either particularly wired or particularly tired. Because when you were playing hide and seek, for example, it would respond immediately, or it would take a few goes and things like that. I thought that was really interesting. Age clock, sometimes they age faster, and another thing that was a lot to do with games was how quickly it got bored. And again, you could start a Furby, and it was like almost just getting bored immediately and wanted to play with you. And there was a really interesting bug that I'll come to with the board timer in a second. So one other thing that everybody talked in the playground was names. And some people just made names up and said it was called certain things, but certainly the source of truth in the source code, that there was just a relatively short list of names. And they're also Furbish, so there was a language, like a lore that was developed around the product. And you can imagine being involved in a team like this where you have such an amazing creative team developing the marketing and the lore and the character development around it, and what those meetings would have been like as an engineer trying to implement some of the crazy ideas that they had, and very exciting. This was one of the bugs that I found. So source control wasn't a particularly common thing in the kind of early 90s, especially for embedded electronics, embedded software. And also we didn't have over-the-air updates. So if you shipped a bug, that thing stayed like that. And there's quite a large number of Generation 1 Furbies that have this bug. And if you find them on eBay, you can sell them for quite a lot of money. And basically the bug was a game mechanic where if you didn't play with it, it got sick, or if you didn't feed it, it got sick. And that kind of kept going. And the only way that you could fix it was to play with it. But what happened was when it got sick, it started not wanting to play with you. So you can see the problem here, and it just was a race to the kind of a rut of the bottom, and eventually it got so sick it didn't want, and you couldn't fix it. And I thought that was interesting. So they implemented this, and you could see basically it was just a code comment, which is effectively a change control. I thought that was interesting. I haven't actually came across any Furbies with this particular bug, but I probably have about 25 at this point. One of the other interesting things a lot of people talked about at the time when they had Furbies was what they got it to do. And Tiger were so good at keeping these a secret. They were never written down anywhere. And in fairness, there's not even today that many places where you'll find this list. I painstakingly pulled this out of the source code. And if you look at the key on the right-hand side, you can see that light just basically means you can cover its eyes, which is a little light sensor, and you play hide and seek with it and things like that. Feed was just that you kind of put your finger in its mouth like a beak, or you give it food. Pet was kind of just petting its back, and tickle was tickling its tummy. And noise, it had a microphone, so you could get noise. And basically, if you did this sequence of things, you got it to do stuff. And one of the interesting things was that a lot of these programs that ran these games were really amazingly and beautifully simple, except one. Simon Says was probably about 40%, 30 to 40% of the entire code base, and incredibly complicated. And one of the things that made it complicated was, it turns out that when you have a Furby with a big motor inside it, it makes a lot of noise. And that it was really difficult to kind of orchestrate all of the kind of different sequences while trying to figure out if you were making noise or not, or yourself was making a noise. The other interesting one was Twinkle Twinkle that I came across, and at the very end of the Twinkle Twinkle program, it basically never let it kind of out of waking back up again. It went into sleep. It basically sang Twinkle Twinkle and it went to sleep. And none of the other programs did this. And I spent a good couple of weeks, why did they do that? Why did they do that? And at the time, I had young kids, and then it kind of dawned on me what was happening there was that, so Furby didn't have an off button. That was also not very happy for the parents. And kids playing with him, waking up in the middle of the night. But you can imagine getting the Furby to sing Twinkle Twinkle with your child. It ends up going to sleep, and they can't figure out how to wake it up. And the only way to wake it up was actually to perfectly invert it. And I thought that was interesting. You can see like such thought went into kind of the features and mechanical and electrical and the software and the lore. So I still wasn't satisfied with how my understanding of how Tiger pulled this off. And this new goal for simplicity, getting back to the start of my story, led me to Furby's secret. And this Sonny Abido dog, I think it was called, came out around the time, and Sonny had this amazing marketing budget, of course, as well, so lots of people also knew about that. But the price difference was insane. And Furby had all of these. It was cool, and I could walk, and I could do lots of really cool things. But Furby was so engaging, and it was just so popular. For $30, how did they do it? And as I was saying earlier, sometimes it takes you to lose your way before the right path emerges. I thought the answer, at the time, around this time in work, I was working on a lot of research and development at KNOS with a lot of computer vision and things like that, and was really fascinated of ways to try and cheat tracking, taking an object and trying to find out where it was in the scene, and if you move it, like where did it move to, and things like that. And certainly at that point, a lot of the new AI tools have made that a lot easier. It was quite challenging, and through that lens, I thought it had to be something to do with how it's moving, or they figured it out, because robots at the time were really expensive. And so I went looking for that, and this is a little tool, like a bit like an endoscope, and you can not very flattering pose for Furby, I'll be honest. And you can see that through this little porthole, basically up its butt, you can see the spinning wheel. And it's stupidly fast. This is actually my iPhone running on slow-mo mode in this video that you just seen there 2 seconds ago. And basically, I tried to depict it here. What's happening here is a little plastic wheel with a hole in it, and a light on the other side, and a sensor on the other side is kind of flying past, and it kind of makes it go like light, dark, light, dark, light, dark. And this is called relative tracking. And what I mean by that is that once you're set up and you're watching it, you can tell, like displacement, you can tell how far it's moved since you started. But the problem with relative tracking is that you never really knew where you started. So you knew its direction, you knew its displacement, but we never knew how it actually started. And this was a difficult problem at the time. It's a bit like having hands of a clock. You never really knew where the numbers were. Maybe a bad analogy, because most of the time the numbers 12 is at the top, but you get the idea. So how do you fix relative tracking? Certainly with cheap electronics these days, the short answer is homing or calibration. And a 3D printer does this. You might notice as soon as you turn a 3D printer on, the first thing it will do is it will just basically drive itself against the wall and hit it. And if certainly the first time that my 3D printer did that, I thought it was breaking, and you try to stop it and you start again, and it just does it again. And Furby basically does this exactly the same. And it doesn't quite look like a button, but basically the idea here is as it's turning around, it hits a button, and at that point it hits that button, you know where the numbers of the clock are, and you just freeze it at that point, and then you can count from there. And this is how Furby does it. But Furby also, so that wasn't the answer. That was cool, but it was a rabbit hole, but it wasn't the answer. Turns out Furby only had one motor. It was right in front of me the whole time. The Sonny Abido dog had all of these motors, like in each leg and arms, and it only had one motor, but it could do all of these things. It had eyelids, it had eyes, it had ears, it could rock back, it had a mouth, it had all of these sensors. It had to be whatever this thing, this gearbox was. It had to be the answer. This little plastic sandwich. But I did not imagine it was anything like this. And the best way to describe what this is this is a super sophisticated analog entirely mechanical state machine, where each wheel here, you can see, has carved in a path to it, which encodes both time and 2 axes of motion for something that's connected to it. So if I take the first little kind of piece, the long piece beside the wheel, imagine it's just kind of like pinned in with a little notch, and as that wheel turns, it's kind of moving that kind of actuator around into different dimensions. And then imagine all of these, like a bit like a clock, I guess, but imagine then you have all these clocks sandwiched in together, and they all interact with each other in really novel ways. And basically, they ended up stacking all these different kind of emotions in a chain and cycling through basically the gearbox to figure out, I want to make it happy, I want to make it sad, I want to make it yawn, I want to make it talk. This was the point in the presentation that I was going to do a demo, but unfortunately she didn't travel well this morning, and she's a little bit grumpy. And I've done this presentation a few times and traveled, and there's always something that breaks when I move it. And unfortunately, I just didn't have a huge amount of time to fix it, or not enough time to fix it in between with the burst water mains on the Shore Road when I was coming in. But I'm going to share a little bit about my experimental setup. So one of the inspirations that I took with this Furby, and in fact, I'll open it here. She looks a lot different. Let me see if I can put the camera on that for anybody. She looks a lot different. She looks very different. Oh, there we go. Very, very creepy. It looks very different with its skin off, right? And a lot of this design, so this is my 3rd version of Furby, and I went through a couple of different iterations where I tried to kind of use the whole piece and I started off trying to use all the different kind of pieces on its own, and it became very complicated. Tried to not use anything, use it as one, and I couldn't get it going fast enough, and it was too noisy, and lots of issues. And one of the pieces of inspiration that I took, I'm sure, like many of you, I follow Disney Research. It's an amazing YouTube channel if you're not following it. And they are currently working on lots of mechatronics, and they have this design that they've been used called the boating cable design. And basically, I implemented that, so I'm just going to whip through quickly just to finish off. So basically, it's all 3D printed, and you see the face is just replicated. So the only part that actually it's real is just the actual eyes and the mouth and the beak and things. Everything else has been constructed. And basically, it's all little fishing wires, just basically pulling bits of its face with little triggers. And the second part that's needed, of course, is something to pull the trigger. And that's a big actuator block, and probably shouldn't try to pick it up. It's quite heavy, but basically it's just a bunch of servos with Bowden tubes, and it just grabs the fishing wire and pulls it, and then inside Furby's face, it has springs or elastic, basically, to help return that. And kind of putting that all together, it ends up kind of looking like this, and the fishing wire basically from the face gets turned into these triggers, and then on the triggers kind of get pulled, and you can see it kind of seesaws almost. In terms of the setup, the technical setup, it's quite complicated, which is why it's hard to set up and hard to move. It doesn't travel well, but basically I use a Teensy 4 microcontroller, so one of the best microcontrollers in the market, very cheap for how fast it is. It can run Arduino, C++, things like that. And I also use, to manage all of the motion control, I use a tool called the Pololu Maestro. And I found that from the Disney Research guys as well. They were using those in the little kind of robots that they have walking around the parks now. And I use a Steam Deck that's just beside me to run, basically coordinate an awful lot of the applications and joypads. And I have a little hidden kind of pad thing that I can press buttons on. And then I have the sound and basically coming from a sound controller that comes through the speaker. So just to finish up, what's next? So honestly, my priority at the minute is reliability. It's really, really challenging to move it, to easier to assemble, but also to make it conversational and presence detection, so I can leave it in conferences and put it in a glass box, let it interact with people on its own, and that's all I have time for. So thank you. Hopefully you enjoyed the day and you enjoy lots of other talks today. And I'm going to be kicking around for probably about the next hour. I probably won't take too many questions. I think I'm out of time anyway. But yeah, I'll be kicking around. Thank you.